We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone.
Hello, greetings to all the viewers out there. I am Professor Jun Cajigal and welcome to this live stream event of the BEDAN Society of Young Astronomers entitled A Tour of the Solar System. So by the title itself, I will be giving you a guided tour of our solar system. So we will be visiting the sun, the planets and their moons, and the other members of the solar system. So isn't that exciting? So before we conduct our guided tour of the solar system, it is just fitting that we first study some of the theories on the formation of our solar system. Now, there are several theories that explains the formation of our solar system. And one of the earliest explanations was provided for by René Descartes. So René Descartes came up with this so-called vortex theory. Now, according to Descartes, God sent adrift a number of vortices of swirling gas. And eventually, these gases change themselves into stars, like our sun, then later into comets, which in turn change themselves into planets. So that was the explanation by René Descartes in his vortex theory. So again, according to Descartes, so God sent adrift a number of vortices. So these are swirling gases, and these gases change themselves into stars, then into comets, then eventually into planets. So that was the vortex theory of René Descartes. Now, another theory that explained the formation of our solar system was provided by Georges Louis Leclerc de Buffon in his so-called collision theory. Now, according to the collision theory, a passing comet tore out some materials from the sun. Okay, so this comet collided with the sun and tore out some of the solar material in space. And the solar materials, they cooled down and eventually formed the planets of the solar system. So to help you visualize the collision theory, so you have here a passing comet. Okay, and this passing comet tore some material out of the sun. And eventually the solar material cooled down and they helped form the planets of the solar system. So hence, this is known as the collision theory. So that comet collided with our sun and tore out some of its materials. The materials eventually cooled down and formed the planets of the solar system. Now that was really fascinating indeed. A comet colliding with our sun. The collision resulted in the tearing of some of the materials out of the sun, and later those materials into space cooled down and formed the planets of the solar system. Okay, so that's the collision theory of Buffon. Now, another theory that explained the formation of the solar system was provided by Kant and Laplace in this so-called Kant and Laplace nebular theory. Now, according to Kant and Laplace, about 4.5 billion years ago, a great cloud of gas and dust called nebula collapses because of gravitational pull and contracts as it spins more rapidly, and this causes the formation of our solar system. Now, to help you visualize the nebular theory of Kant and Laplace, I want you now to zoom in on this diagram. So, at around 4.5 billion years ago, there was this great cloud of gas called nebula. And eventually, gravity comes in and gravity contracts or collapses this nebula. And eventually, this nebula begins to spin as it collapses, forming a disk. Okay, so the disk begins to rotate or to spin. And eventually, at the center of the disk, there's the formation of a central mass which will eventually form our sun, known as a proto-sun. And centrifugal force comes into the picture. The centrifugal force, as the gas begins to spin, form rings around that proto-sun. And eventually, the rings form the planets of the solar system. So that's Kant and Laplace nebular theory in the formation of our solar system. And that's the nebular hypothesis or theory of Kant and Laplace. So according to them again, at around 4.5 billion years ago, there was this great cloud of gas called nebula. Then gravity comes into the picture. Gravity begins to collapse this nebula and forms it into a spinning disk. Then eventually, at the center of the disk, you have there a central mass which we now call as the proto-sun. And that proto-sun will eventually form our own sun. And centrifugal force begins to form rings around that proto-sun. And those rings begin to collapse and condenses to form eventually the planets of the solar system. Now, another explanation in the formation of the solar system was provided by JEANSJEFFREYS, the so-called JEANSJEFFREYS tidal hypothesis. Now, according to this explanation, a passing star is supposed to have pulled out a long strand of gaseous material from the sun, and it soon looked like beads on a string. Then these then form themselves into the planets of the solar system. So to help you visualize this so-called tidal hypothesis, so everybody kindly take a look at this illustration. So you have here a passing star, and because of the gravitational pull of that star, it begins to pull out some of the material from the sun. This material from the sun look like beads on a string, and those beads begin to cool down and eventually form the planets of the solar system. Okay, so tidal, just like the tides here on Earth. So the moon's gravitational pull attracts the waters of the earth, creating tides. So just like in the explanation of JEANSJEFFREYS, this passing star begins to pull some of the materials out of the sun, looking like beads on a string. So that's the so-called the tidal theory or the tidal hypothesis of JEANSJEFFREYS. Now, another explanation in the formation of our solar system is the so-called solar nebula hypothesis. Now, this hypothesis or theory is quite similar to the Kant and Laplace nebular hypothesis. The only difference is that around 4.5 billion years ago, there was an explosion of a star called a supernova. And this supernova explosion caused the nebula to collapse, forming a central mass called a protostar, which will eventually form our sun. Then after 10 million years, then later, you have now the formation of the protoplanets surrounding that central mass or protostar or protosun. Okay, so to help you visualize the solar nebular hypothesis, everybody, please take a look at this illustration. So, at around 4.5 billion years ago, you have there the supernova explosion. This supernova explosion allowed the collapse of this nebula, eventually forming a disk with a central mass called a protostar or a protosun. So this protostar or protosun will eventually form our own sun. And surrounding the protostar or protosun are gases which will eventually form the protoplanets. And the protoplanets, eventually after millions of years, will form the planets of the solar system. Okay, quite fascinating, isn't it? Alright, here's an animated illustration to further help you visualize the solar nebular hypothesis. So the explosion of that supernova will allow the collapse of the nebula, forming a central mass called a protostar or a protosun. Then surrounding the protostar or protosun, you have the gases, which in turn will form the protoplanets. And the protoplanets, after millions of years, will form the planets of our solar system. Okay, so that's the solar nebular hypothesis. Alright, so again, you have here the nebula. The nebula collapses because of the supernova explosion. Eventually, the collapsing nebula forms a central mass called a protostar or protosun, which will eventually form our sun. And surrounding the protostar, you have the formation of the protoplanets, which in turn will form the planets of the solar system. Okay, so at this point, let us now study the so-called scale of the solar system. Now, most probably you have seen pictures from the internet on how our solar system is represented. So most probably you have seen pictures something like this. Okay, we have the sun and the planets of the solar system. Now, this picture of the solar system is not in scale. So this is not the true distances of the planets with each other and from the sun. Okay, here's another picture of the solar system, or how the solar system is represented. So the picture is not in scale. This is not the true distances of the planets from each other and their distance from the sun. So do you want to know the scale of our solar system? Now, to give you an idea, let's take a look at this picture of the Philippines, which is superimposed with this picture of our moon. Okay, so you would be surprised that the moon is much bigger than the Philippines. So this is a scaled picture of our country superimposed with that of the moon. So mas malaki pa ho ang buwan natin as compared to our country. Kasi akala natin malaki ang Pilipinas, right? But the moon is much bigger than the Philippines. Okay? Alright. Now, with regards to the distance of the moon from the Earth, the moon is about 384,400 kilometers away from us. Or that's about 238,555 miles. So that's the distance of the moon from the Earth. Now, you will be surprised that all of the planets can fit in that space between the moon and the Earth. So the planets including Mercury, Venus, Mars, Jupiter, Saturn, Uranus, and Neptune, they can all fit in that distance between the moon and the Earth. So what I'm trying to say, ladies and gentlemen, is that the moon is really far. Malayo po ang buwan. And it took 4 days for the Apollo spacecraft just to reach the moon. Okay? So that's how far the moon is from the Earth. Now that is really fascinating about the distance of the moon from the Earth. So all the planets can fit in that distance between the moon and the Earth. So talagang malayo po ang buwan. Okay? But if we look up at the night sky, parang tanaw na tanaw natin yung buwan. So parang kayang-kaya natin siyang dukutin. But the moon is really far. And again, like what I mentioned, it took 4 days for the Apollo spacecraft to reach the moon. Alright, so do you know the true distances of the planets from each other and from the sun? Alright, so let's take a look at this aerial photo of San Beda University. So ito po yung school natin, San Beda University. And at the center of this circle is the conference hall. This conference hall represents the sun. Okay, then this blue circle represents the orbit of Mercury. So, malapit lang po ang Mercury sa Sun. Alright? Then this yellow circle represents the orbit of Venus. So, malapit din po yung Venus sa Sun. Okay? And this blue circle represents the orbit of planet Earth. Okay, so you can imagine, nandun pa rin sa loob ng campus. So, come to think of it, malapit lang po tayo sa sun. Okay? Alright, then this red circle represents the orbit of the planet Mars. Okay, so hindi pa rin po lumalabas yung orbit ng Mars sa campus. So, tumama lang siya dun sa parking area ng mga buses. Alright. Then, there is this huge gap. Malaki po yung space dito. And this circle, this big circle, represents the orbit of Jupiter. So, the mighty Jupiter, ito po. So, this gap is occupied by the asteroids. So, this is the so-called asteroid belt between the orbits of Mars and Jupiter. So, everybody look at the orbit of Jupiter. Lumabas na siya po sa San Beda. So, nasa Menjola Street na ho. At tumama na siya sa CEU. Okay, that's the university in front of San Beda. Okay, so tumama na yung orbit niya dun sa CEU. Okay, so this is the orbit of Jupiter. Okay, so beyond the orbit of Jupiter is Saturn. So everybody look at this. So this yellow big circle represents the orbit of Saturn. Okay, so ang layo na ng Saturn. We started here sa conference hall ng San Beda. And lalabas tayo ngayon ng campus. So this is the orbit of Saturn. So ang layo. Okay? Fascinating, isn't it? Okay? Then beyond the orbit of Saturn is Uranus. Alright, so this blue-green circle represents the orbit of Uranus. So look at the conference hall of San Beda, lumiit siya, and this is the orbit of Uranus. Ang layo na. So tumama na siya sa UE and parts of Sampaloc. Fascinating, isn't it? So ang layo na ng Uranus, no? From the sun, from the conference hall of San Beda. Okay? Alright, and beyond Uranus is Neptune. So this big blue circle is Neptune. So ang layo na, tumama na siya sa Pasig River. Look. Okay? So siguro tumama na rin siya sa Malacanang and big part of Sampaloc. So again, we started our journey here sa conference hall at San Beda University. And look at the orbit of Neptune. Fantastic. Ang layo. See? Fascinating, isn't it? And beyond the orbit of Neptune is the Kuiper Belt. Ito po, that's the Kuiper Belt. So, ang layo. That's the scale of the solar system. Ganon kalalayo ang mga planets from each other and from the sun. Okay, so wasn't that really fascinating about the scale of our solar system? So talagang malalayo po ang mga planeta. Okay, so in the case of Mars, so a spacecraft would take about 7 months just to reach Mars. Okay, for Jupiter, if you're planning to go to Jupiter, it would take about 5 to 6 years. Saturn, about 8 years. So, malayo po. Malayo po talaga mga planeta. And, did you know that the New Horizons space probe took about 9 years just to reach Pluto? Alright? So that's how far the planets are from each other and from the sun. And this is what astronomy teaches us. Astronomy teaches us to be humble. Kasi talagang malit lang tayo in the scale of the solar system and in the scale of the universe. We are just a speck of a speck of a speck. So that's what astronomy teaches us. Astronomy teaches us to be humble. Okay? And it's really mind-blowing yung mga distances ng mga planets. And even sa mga stars, malalayo po sila. Okay, so I guess we can now move on to the discussion of the planets of the solar system. Okay, as we all know, our planets are classified as follows. So we have the inner rocky planets, and we have the outer gas planets. So the inner rocky planets includes Mercury, Venus, Earth, and Mars. And the outer gas planets includes Jupiter, Saturn, Uranus, and Neptune. Okay, that's how the planets are classified. The inner planets that includes Earth, these planets are small with a rocky surface, no rings, few moons. In fact, for the inner planets, our planet Earth and Mars has moons. Okay, Mars has two moons, Phobos and Deimos. The Earth has one natural satellite, that's our moon. Venus and Mercury, they don't have moons. Okay, also the inner planets, they don't have rings surrounding them. And they're quite hot because of their distances from the sun. Okay, while the outer planets, they're big, and basically, as the name indicates, they're made of gas, and they have rings. Jupiter has rings. Saturn has some magnificent rings surrounding it. Uranus and Neptune also has ring systems of their own. And these gas planets, they are orbited by many moons. Like Jupiter is orbited by 64 plus moons. And because of their extreme distance from the sun, these gas planets are really cold. Now, planets can also be classified as major and dwarf planets. So the major planets includes Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. While the dwarf planets includes the following. So we have Ceres, though Ceres is within the asteroid belt. Ceres is big enough to be considered as a dwarf planet. Also, Pluto. Before, Pluto was classified as one of the major planets. But Pluto was demoted. Okay? But that's another story. Okay, Pluto was demoted into a dwarf planet status. Okay? So, planets can also be classified as major and dwarf planets. Now, as I have promised, I'll be giving you a guided tour of our solar system. So let's imagine that we are on board the USS Enterprise headed by Captain James T. Kirk with Spock and Dr. Leonard McCoy with him. And we will travel where no man has gone before. So come with me and let us visit the planets of the solar system. So we will now travel at warp speed on our way to our first destination. So we will now visit the planet Mercury. So that's the symbol of the planet Mercury. The planet was named after the Roman messenger of the gods. The Greek counterpart of Mercury is Hermes. Okay, so let us now place our starship in parking orbit around Mercury, and let us now activate our sensors so that we can gather information or data about the planet Mercury. Okay, Spock, please activate the sensors and let's gather data about the planet Mercury. Now, in terms of its rotation on its axis, Mercury takes about 59 Earth days to spin on its axis. So, one Mercurian day is equivalent to 59 Earth days. So, medyo mabagal po ang pag-ikot ng Mercury on its own axis. Okay? But, Mercury takes about 88 Earth days to complete one revolution around the Sun. So that's quite fast. Mabilis po yan sa solar system natin. That's why the planet was named after the Roman messenger of the gods. So 1 Mercurian year is equivalent to 88 Earth days. Unlike here on Earth, 1 Earth year is equivalent to 365 days. 1 Mercurian year takes only about 88 Earth days. Now, this means that 1 day on Mercury lasts a lot longer than a day here on Earth. So here on Earth, 1 day is equivalent to 24 hours. But 1 Mercurian day takes about 59 Earth days. So medyo matagal po ang isang Mercurian day. And in terms of its axis, the axis of Mercury is tilted only by 0.1 degrees. So medyo halos nakatayo na po ang planeta on its axis. The tilt of the Mercurian axis is only 0.1 degrees. Okay, so to continue, Mercury lacks an atmosphere. So walang atmosphere ang Mercury. So what's the implication of that? So without an atmosphere, there is no way for the planet to regulate its temperature, much like the moon. Okay? And because of the absence of an atmosphere, the side facing the sun experiences temperatures as high as 420 degrees Celsius. And then the side facing away from the sun, the temperature goes down to about negative 173 degrees Celsius. So isn't that fascinating about Mercury having no atmosphere at all? So there is no way for it to regulate its temperature. Alright, so let us now compare Mercury in terms of size with that of planet Earth. So let's take a look at this picture of our planet and Mercury. So it is obvious that Mercury is a lot smaller than the Earth. Okay? And if we will compare Mercury and our own moon, Mercury is slightly larger than our moon. And Mercury is scarred by millions of impact craters, much like the moon. Now, in terms of size, comparing Mercury and our moon is only 3,476 kilometers in diameter. Mercury is about 4,880 kilometers in diameter. So, Mercury is slightly larger as compared to our own moon. And again, like what I mentioned, Mercury is scarred by millions of impact craters very similar to the moon. That's why Mercury has a surface much like that of our moon. Mercury has a lunar-like landscape. So isn't that fascinating that the surface of Mercury is much like that of our own moon? Okay, so these are pictures of Mercury, and as you could see, Mercury is scarred by millions of impact craters, very similar to our moon. That's why Mercury can be described as a planet with a lunar-like landscape. Okay, so that's the planet Mercury. And in terms of craters, the largest crater on the planet Mercury is the so-called Caloris Basin. The Caloris Basin is the largest impact crater on the planet Mercury. But Caloris Basin is not the largest impact crater in the solar system. The largest impact crater in the solar system is on the planet Mars. Okay, so that's the Caloris Basin, and this is the rim of the Caloris Basin. So malaki din po siya. Okay? So this is the Caloris Basin. The Caloris Basin is the biggest impact crater on the planet Mercury. Fascinating, isn't it? Okay, so that's the Caloris Basin, the biggest impact crater on the planet Mercury. Okay, what about the interior of Mercury? Now, the interior of Mercury has a large metallic core, and it is over 60% denser than the Earth's moon. Okay, everybody please take a look at this. So, Mercury has a very large metallic core in comparison to its crust and mantle. Look at our planet Earth. So, this is the core of the Earth, and look at the mantle and crust. So, medyo makapal yung crust and mantle as compared to the core. But on Mercury, Mercury has a very large metallic core. So, malaki po yung core ng Mercury. Alright? So, everybody, take a look at this. So, this is the interior of our planet, and this is the interior of Mercury. So, Mercury really has a large metallic core. Manipis lang yung mantle and crust. Okay, in contrast to the Earth. So, this is the core of the Earth. Makapal po yung mantle and yung crust niya. Okay, in comparison to Mercury. Alright, so that's quite fascinating about Mercury. And because of that, Mercury is one of the densest planets in the solar system. Okay, so Mercury has a very large metallic core. Okay, and Mercury has only been visited by 2 spacecrafts. One was Mariner 10 back in the mid-1970s. So that's Mariner 10. And in 2008, the spacecraft Messenger made a close flyby to Mercury and taking images of the surface of the planet. Alright? So Mercury has only been visited 2 times by spacecraft. One was Mariner 10 in the mid-1970s, and in 2008, Mercury was visited by the Messenger space probe. Okay, so this is Mariner 10, and this is the Messenger space probe. Okay, so I guess that's it for our visit to the planet Mercury. Though Mercury is the closest planet from the Sun, Mercury is not the hottest planet. The hottest planet will be our next stop on our journey to the solar system. The hottest planet is the planet Venus. Okay, so we will now beam back to our starship, and let us now travel at warp speed on our way to our next stop on our journey to the solar system. So we will now go where no man has gone before. So we shall now visit the planet Venus. Okay. Alright, so that's the symbol of the planet Venus. Now the planet was named after the Roman goddess of beauty and love. The Greek counterpart of Venus is Aphrodite. Okay, so that's Venus. And let us now park our starship in orbit around Venus. And let's activate again our sensors so that we can gather information about the planet Venus. Alright, Spock, kindly activate the sensors and let's gather data about the planet Venus. Alright, so that's the planet Venus. Now, Venus is said to be the Earth's twin. Okay, almost virtual twin of Earth in terms of size and mass. Okay, Venus orbits at an average distance of about 108 million kilometers and completes an orbit around the Sun every 224 Earth days. So one Venusian year is about 224 Earth days. Okay, so in terms of size, Venus is said to be the Earth's twin. Look at the size of Venus. Its diameter is 12,190 kilometers. Compare that to our planet. The diameter of the Earth is 12,756 kilometers. So the Earth is just slightly larger than Venus, but almost pareho sila ng size. Okay? That's why Venus is said to be the Earth's virtual twin. Okay? Pero malayo po. Hindi talaga sila sa size lang, but malayo ang Venus sa Earth, as you will see later. Alright. So, we can see Venus in the night sky. Like at this time, so makikita po ang Venus in the early morning. So madaling araw, kitang-kita po yung Venus in the eastern part of the sky. Okay? So if you're familiar with the night sky, if you're an amateur astronomer, yan, gumising kayo po ng mga 4 o'clock. Yan, you can spot Venus in the eastern sky. Okay, so that's the location of Venus. And this was observed by Galileo, okay, through his telescope. When he pointed his telescope towards Venus, Galileo saw Venus changing shape, okay, from crescent to first quarter, much like that of the moon. And this was the turning point for Galileo to support the Copernican model of the universe. So I hope you still know the story of Galileo. Okay? So this observation of the changing phases of Venus was the turning point for Galileo to support the Copernican model of the universe. Okay, and in this picture we could see Venus making a transit across the face of the Sun. So ayun po yung tinatawag natin na transit, when Venus crosses the face of the Sun. Okay, and look at the tilt of the Venusian axis. Compare that to the tilt of the Earth's axis. So halos nakatayo din ng Venus. Okay, ang Earth kasi natin nakatilt siya for about 23.5 degrees. So ang Venus maliit lang yung kanyang tilt. Okay? All right. So that's Venus. And what is so amazing about Venus is the direction of its rotation on its axis. Okay, the Earth rotates on its axis in a counterclockwise direction. Now, look at Venus. Ang Venus po baliktad. Venus rotates on its axis in a clockwise direction. So, we call that retrograde rotation. Okay? So, if you're on Venus, pag nasa Venus po kayo, the sun will rise in the west and it will set in the east. Unlike here on Earth, kasi yung rotation po natin ay counterclockwise. So, the sun rises in the east and it sets in the west. Okay? Now, why? Bakit kaya ganito yung rotation ng Venus? Why is it that the rotation of Venus on its axis is retrograde, clockwise? Now, the reason for that is that during the early development of Venus, in its early history, Venus encountered an off-center collision with a massive protoplanet. So, nagkaroon ng collision between Venus and a large protoplanet that shifted its rotation from counterclockwise to clockwise. Okay? Venus rotates clockwise in a retrograde rotation once every 243 Earth days, which is the slowest rotation of any planet. Okay, so that's quite fascinating about Venus. Venus exhibits what we call a retrograde rotation, or Venus rotates in a clockwise direction as compared to Earth. The Earth rotates in a counterclockwise direction. And again, the reason for that is that during the early history of Venus, Venus encountered a collision with a protoplanet. And this protoplanet had shifted its rotation from counterclockwise to clockwise. Okay, so that's the reason why Venus exhibited a retrograde rotation on its axis. So, nakipagbungguan ang Venus with a protoplanet that shifted its rotation. At yun din po ang dahilan kaya naging mabagal ang rotation ng Venus, which is the slowest in the solar system. Okay? Alright, so this is Venus, planet Earth, and Mars. So again, Venus is said to be the Earth's virtual twin. Alright, so what about the atmosphere of Venus? Now, the Venusian atmosphere is extremely thick. Okay? And the Venusian atmosphere is composed mostly of carbon dioxide. And because the Venusian atmosphere is so thick that the atmospheric pressure is 90 times greater than that of the Earth. So, para kayong nasa ilalim ng dagat. That's the atmospheric pressure of Venus. Again, because of its extremely thick atmosphere. Okay? Alright, everybody, can you take a look at this pie chart of the composition of the Venusian atmosphere? So, the Venusian atmosphere is composed mostly of carbon dioxide, about 96.5%. Okay? Alright, so isn't that amazing about the planet Venus? Okay, and the remaining 3.5% is nitrogen. Other gases includes argon, sulfur dioxide, a bit of water vapor, carbon monoxide, and other inert gases. So that's the composition of the Venusian atmosphere. Okay, quite amazing, isn't it? And because of the extreme thickness of the Venusian atmosphere and the fact that carbon dioxide is a greenhouse gas, Venus exhibits what we call a runaway greenhouse effect. Plus the fact that the Venusian clouds is made up of sulfuric acid. So, yung ulap po ng Venus, yung thick Venusian clouds, it's composed of sulfuric acid. Asido po ang composition ng Venusian clouds. Okay? Fascinating, isn't it? Plus the fact that the Venusian atmosphere is thick and it's made up of carbon dioxide. So, Venus exhibits what we call a runaway greenhouse effect. So, as the sun's radiation penetrates the Venusian atmosphere, the radiation in the form of heat gets trapped inside the Venusian atmosphere. Okay? Because we know that carbon dioxide is a greenhouse gas. So, the heat from the sun gets trapped inside the Venusian atmosphere. And what's the consequence of that? So, the global temperature on Venus increases drastically. So, para kayong nasa pressure cooker niyan. So, this would make Venus the hottest planet in the solar system. So, on Venus, there is way too much carbon dioxide. And this creates a runaway greenhouse effect. So, the planet never cools off. So talagang mainit sa Venus because of this runaway greenhouse effect. Okay, so the sun's rays penetrates the Venusian atmosphere but the heat doesn't escape. So talagang mainit po sa Venus. Alright? So Venus exhibits what we call a runaway greenhouse effect, and this makes Venus the hottest planet in the solar system. Alright, so this is what Neil deGrasse Tyson mentioned about Venus as he describes it. If Earth ever suffers a runaway greenhouse effect, like what has happened on Venus, then our atmosphere would trap excess amounts of solar energy, the air temperature would rise, and the oceans would swiftly evaporate into the atmosphere as they sustained a rolling boil. This would be bad. Okay? So that's the condition of the Venusian atmosphere. Thick clouds of sulfur dioxide generates the strongest greenhouse effect in the solar system, creating surface temperatures of at least 462 degrees Celsius. And this makes the Venusian surface hotter than Mercury. So this makes Venus the hottest planet in the solar system. Amazing, isn't it? Now, if you are a visiting astronaut, what would you experience on the planet Venus? Now, an astronaut on the planet Venus would experience 90 times the pressure of the Earth's atmosphere with incredibly high temperatures. So, ang astronaut parang nasa ilalim ng dagat. Okay? And mataas, mainit, incredibly high temperatures, and poisonous clouds of carbon dioxide and sulfuric acid. Okay? So, yun ang may experience ng astronaut pag bumisita siya sa Venus. So, ang ganda ng pangalan, no? Venus being the goddess of beauty and love. Pero yung planeta parang impyerno. Okay? So, Venus is one hell of a landscape. Okay? Parang ironic because the planet was named after the goddess of beauty and love. Pero yung topography niya, yung conditions, talagang hellish. So, para kayong bumisita sa impyerno. That's what you experience on the planet Venus. Alright. And there are also volcanic features on Venus. But they are not that active as compared to the volcanoes here on Earth. Okay? And this picture was taken by the Venera space probe. So look at the sky. Okay? So yung sky niyan is yellow, indicating the presence of sulfuric acid. So fascinating, isn't it? All right. So in terms of exploration, Venus has been visited by the Venera space probes of the Russians. So Venera 3 landed on Venus on March of 1966. It was the first man-made object to enter the Venusian atmosphere and strike the surface of another planet. Its communication system failed before it was able to return any planetary data. So it was the Russians who spearheaded the exploration of Venus. Then on October 18, 1967, Venera 4 successfully entered the Venusian atmosphere and was able to deploy science experiments. Then Venera 4 showed the surface temperature was even hotter than Mariner 2 had measured at almost 500 degrees Celsius. Ang init! and the atmosphere was 90 to 95% carbon dioxide. Okay, so the Russians spearheaded the exploration of Venus with their Venera missions. Okay, so this is a picture taken by the Venera probes in 1981. So look at the sky, the Venusian sky. It's yellow, and that means that the sky is composed of sulfuric acid. The clouds are made of sulfuric acid. Okay, so that's quite fascinating. All right, so that's the Venera missions on Venus. All right, the most recent spacecraft sent to Venus is the European Space Agency's Venus Express. It arrived at Venus in 2006 and has been making continuous observations of the planet ever since. Okay. All right. So I guess that's it for our visit to the planet Venus. So we are now ready to beam back to our Starship Enterprise. And we shall now board the USS Enterprise to continue with our journey through the solar system. So let us now travel at warp speed on our way to our next stop in our journey through the solar system. So we shall now visit the most intriguing planet of them all, the planet Mars. Now that's the symbol of Mars. The planet was named after the Roman god of war. The Greek counterpart of Mars is Ares. So let us now activate our sensors and let us now scan the planet so that we can gather information and reveal the secrets of Mars. So, Mr. Spock, kindly activate our sensors and let us sweep the surface of the planet so that we can gather information about this mysterious red planet called Mars. Now, Mars, in terms of size, is about 1/2 of the Earth's diameter. Okay? And in terms of its atmosphere, Mars exhibits a very thin atmosphere. And the atmosphere of Mars, the Martian atmosphere, is composed mostly of carbon dioxide, which is similar to the Venusian atmosphere. If you will recall, the Venusian atmosphere is also composed mostly of carbon dioxide. So with the Martian atmosphere is also composed mostly of carbon dioxide. The only difference is the thickness. The Venusian atmosphere is extremely thick, but the Martian atmosphere is extremely thin. Alright? Okay. Rotation period of Mars, that's about 24 hours and 40 minutes, which is very similar to Earth. Here on Earth, 1 day is equivalent to 24 hours. 1 Martian day is 24 hours and 40 minutes. So, very close to our planet. Okay? Alright. Also, the axial tilt of Mars is 25 degrees, which is very close to Earth. The axial tilt of the Earth is about 23.5 degrees. Okay? So, what is now the implication of this? That the axis of Mars is tilted by 25 degrees. So, the consequence of that is that Mars also manifests seasonal changes. Okay? And we observe that by the growth and shrinking of the polar ice caps of Mars. Okay? Now, that is really fascinating about the planet Mars. Since the Martian axis is tilted by 25 degrees, which is close to Earth, so that means that Mars exhibits seasonal changes very similar to Earth. And we observe that in the growing and shrinking of the polar ice caps. So we will go into that later. Now, the Martian crust is not broken into tectonic plates. Though Mars is now geologically dead or geologically inactive, there are volcanoes on the planet Mars. In fact, the largest volcano in the solar system is in the planet Mars. Okay, so let's look at this photo of the polar ice caps of Mars. So, if the polar ice caps is of its maximum size, that means that it is the Martian winter. Okay? And if the polar ice caps is of medial size, that means that it is mid-spring. And if the polar ice caps is of its minimum size, that means that it is the Martian summer. Really fascinating indeed, ladies and gentlemen. Okay, so let us now do some comparison between Earth, Mars, and Moon in terms of size. Okay, so as we have mentioned a while ago, Mars is about 1/2 of the Earth's diameter. Okay, so everybody kindly zoom in on this animated illustration of the sizes of these three celestial objects, Earth, Mars, and our own Moon. So the Earth is about 7,926 miles in diameter. Mars has a diameter of about 4,220 miles. So that's about half of the Earth's diameter. Our Moon is about 2,159 miles in diameter. So that's in terms of size. Mars is about 1/2 of the Earth's diameter. Okay? Alright, so that's really fascinating indeed. Now, in terms of volume, it would take more than 6 Mars to fill the volume of the Earth. So that's interesting. It would take more than 6 of Mars to fill the volume of the Earth. Okay, and let's talk about now its gravity. Since Mars is smaller than the Earth, about half of its diameter, then on Mars you would experience 62.5% less gravity than you're used to. So if you can jump here on Earth, those tiny teensy jump, on Mars, you can do kangaroo hops on the red planet. Okay? Yan, so pwede kayong tumalon, pwede kayong mag-basketball, pwede kayong mag-dunk pag nasa Mars na kayo because you can jump really high because of its less gravitational pull. And that's really fascinating indeed, right? Okay, so you would experience 62.5% less gravity than you're used to. Now, since the gravity of Mars is less as compared to Earth, so that means that you would weigh less on Mars as compared to Earth. In fact, if you are 100 pounds here on Earth, on Mars, you would weigh only 38 pounds. See? Because of its less gravitational pull. Okay? So if you weigh 100 pounds here on Earth, on Mars, you would weigh 38 pounds. So kung gusto niyo po magbawas ng timbang, pumunta po kayo sa Mars. Okay, joke lang po yun. Alright, so 100 pounds here on Earth, you would weigh only 38 pounds on Mars because Mars exhibits less gravitational pull. Okay, and that's really interesting about the planet Mars. Okay, so let's talk about now this unusual movement of Mars. So this was observed by our early astronomers from Eudoxus to Aristotle to Ptolemy, Copernicus. So this movement of Mars and all the planets as well is called retrograde motion. So the planets, especially Mars, they move from west to east. Then Mars turns back west. and then loops around and goes to its easterly course. Okay, so this is what we call retrograde motion of Mars. So Mars moves from west to east, then it turns back westward as so, goes back west and loops around and returns to its easterly course. So that's retrograde motion of Mars. Now that is really interesting about the retrograde motion of Mars. Okay, let's now study the Martian atmosphere. Now, like what I have mentioned a while ago, the Martian atmosphere is really thin. And because of that, the pressure exerted by the Martian atmosphere is less. Okay, about 1% of the pressure here on Earth. Okay, so para po kayong nasa taas ng Mount Everest. That is how thin the Martian atmosphere is, and ganun po kaliit ang pressure niya. So if you're on the Martian surface, you need to wear a spacesuit or else mamamatay po kayo. The Martian atmosphere is thin, and because of that, the pressure exerted by the atmosphere is really less, about 1% of pressure on the Earth's surface. Now, in terms of composition, the Martian atmosphere is composed of 95% carbon dioxide, which is similar to the Venusian atmosphere. The Venusian atmosphere also is composed mostly of carbon dioxide. The only difference is that the Venusian atmosphere is extremely thick, while the Martian atmosphere is very thin. Okay? And even though the Martian atmosphere is really thin, the Martian atmosphere exhibits some activities like high-speed winds, haze, clouds that hover the planet, and even occasional dust storms. Okay? So the Martian atmosphere also exhibits dust storms that can enshroud the entire planet. And that's really fascinating indeed. Now, let's take a look at the Martian atmosphere in more detail. Okay, so as compared to the Earth's atmosphere, the Martian atmosphere is really thin. The Earth's atmosphere is over 100 times denser than the Martian atmosphere. Now, in terms of composition, the Martian atmosphere is composed, again, mostly of carbon dioxide, about 96% carbon dioxide. And you have 2% argon, 2% nitrogen, and 1% other gases. Okay, here on Earth, the Earth's atmosphere is composed mostly of nitrogen, about 78% nitrogen, and 21% oxygen. Alright, so that's how we compare the Martian atmosphere with that of the Earth's atmosphere. And even though the Martian atmosphere is really thin, there are occasional dust storms, and there are also clouds and haze in the Martian atmosphere. So there's some activity in the Martian atmosphere in the form of clouds, haze, and occasional dust storms that may enshroud the planet. So that's really interesting indeed about the Martian atmosphere. And again, look at this pie chart of the composition of the Martian atmosphere. So again, the Martian atmosphere is composed mostly of carbon dioxide. Okay? And other gases may include argon, nitrogen, carbon monoxide, and traces of inert gases. Okay? So that's the composition of the Martian atmosphere. Now, I want you to take a look at this photo of the Martian terrain taken by the Viking space probe. So you will notice that the Martian terrain resembles that of a desert. Okay? And the fact that Mars is farther from the sun as compared to Earth, you would expect freezing temperatures. So the best description that we can give to the Martian terrain is that the Martian terrain resembles that of a frozen desert. So para pong disyerto dito sa Earth. para po siyang nasa Death Valley. Okay, if you're familiar with Death Valley in the United States. So, ganun po ang Martian terrain. Plus the fact, yung temperature po niya ay sobrang lamig para po kayong nasa Antarctica. Okay? And you will notice that the Martian soil is red. Okay? Now, the reddish coloration of the Martian soil is due to iron oxides present in the Martian soil. Okay? So, the Martian soil has iron oxides or rust, kalawang. And that accounts for the reddish coloration of the Martian soil. Alright, so fascinating, isn't it? Okay? Look at these photos taken by Viking. So, you will really notice that the Martian terrain resembles that of a desert, much like that of Death Valley. So, if you're familiar with Death Valley, parang ganyan po ang Death Valley sa US. Yan, ganyan po ang Martian terrain. And the soil is red because of iron oxides. Okay? And Mars is inhabited. Okay? Mars is inhabited by several robotic rovers. So, Mars is the only planet inhabited by robots. Okay, like Pathfinder, Curiosity, okay, Opportunity rover, and the Perseverance rover, which is on its way to Mars. Okay, so let us now study the geology of Mars. Now, Mars has giant volcanoes, so we'll talk about them later, valleys like Valles Marineris, and Mars also is scarred with millions of impact craters, much like that of the moon, since the atmosphere is so thin that it offers little protection from meteorite bombardments. Okay? And let's talk about now the volcanoes on Mars. Now, this volcano known as Olympus Mons is the largest volcano on Mars, and this is also the largest volcano in the solar system. Okay, it is so huge that Olympus Mons can be seen in orbit. Okay, ayan po, napakalaki ng Olympus Mons. Kitang-kita sa outer space. Ito. Alright? And Olympus Mons is so big, it is 3 times higher than Mount Everest. Okay, Olympus Mons on Mars is 27 kilometers tall, almost 3 times the height of Mount Everest. Fascinating, isn't it? Ang laki ng Olympus Mons. So siguro pag nasa Mars kayo at nasa foot kayo ng volcano, ay mamamangha kayo sa laki ng Olympus Mons. Olympus Mons is 3 times higher than Mount Everest. Okay? Fascinating indeed of Olympus Mons. And Olympus Mons can be seen in orbit kasi ang laki-laki po niya. Okay? So, if you're on the planet Mars and if you're on the foot of that volcano, ay nako, mamamangha kayo sa grandeur and splendor of Olympus Mons. Alright, this is Valles Marineris. Valles Marineris is called the Grand Canyon of Mars. Okay, kitang-kita po siya sa orbit. Malaki po ang Grand Canyon of Mars, which is Valles Marineris. This is a vast canyon system that runs along the Martian equator. Valles Marineris is 2,500 miles long, okay, and reaches depths up to 4 miles. Okay, Valles Marineris stretches from New York to California in the United States. Ganun po kahaba ang Valles Marineris. Okay? Mahaba, malaki ang Valles Marineris. And Valles Marineris is 150 miles wide and 4 miles deep. Compare that to our own Grand Canyon, which is only 18 miles wide and a mile deep. Wow! Isn't that fascinating? So wala pong sinabi ang ating Grand Canyon here on Earth. Our Grand Canyon is only 18 miles wide and 1 mile deep. Compare that to Valles Marineris, which is 150 miles wide and 4 miles deep. That is so fascinating. Ang laki ng Valles Marineris. Okay? Alright, so imagine yourselves at the edge of Valles Marineris. Kung astronaut po kayo sa Mars, mapapamangha po kayo sa laki ng Valles Marineris. Babagsak po ang jaw ninyo. Okay? Once you're along the edge of Valles Marineris. Fascinating, isn't it? Okay, that's Valles Marineris. Valles Marineris, again, is said to be the largest canyon in the solar system. Now, what about impact craters on Mars? Now, the largest impact crater on Mars is Hellas Planitia. Hellas Planitia is the largest recognized impact basin on Mars and in the solar system with an estimated diameter of 3,300 kilometers. Ang laki po niyan. Okay? So this is the outline of Hellas Planitia. So Hellas Planitia is actually the largest recognized impact basin. Alright, this is Hellas Planitia compared to the area of the United States. So malaki po siya talaga. Okay, Hellas Planitia is a plain located within the huge, roughly circular impact basin. Again, with a diameter of 3,300 kilometers. Malaki siya talaga. Okay? And Hellas is said to be the largest visible impact crater known in the solar system. So, isn't that mind-blowing? Alright? The largest volcano is on Mars. The largest canyon system is on Mars. And the largest impact crater is on the planet Mars. Now, what about water on Mars? Now, Mars is one of the several members of the solar system that might sustain life. Again, many astronomers believe that water may be present on the red planet. In astrobiology, the search for life outside planet Earth is the search for water. But on Mars, water cannot exist in liquid form. Again, because of its pressure. The atmospheric pressure on Mars is so low that water will simply evaporate. Alright? But there is evidence to prove that water may have flowed on the Martian surface. Now, astronomers have discovered geologic features that resemble dried up riverbeds or canals or channels. Okay, and that's fascinating. These canals or channels may represent dried up riverbeds, and these canals or channels may have been carved by running water. Okay, so these canals may have been carved by running water, and that's an evidence to prove that in the early history of Mars, water may have flowed on the Martian surface. Okay? So, isn't that fascinating about these canals? These canals may represent dried up riverbeds that may have been carved by running water. Okay, now that's really fascinating about water on Mars. Now, water may not exist in liquid form, but water may exist in solid form in the polar ice caps, which we will be mentioning later. Now, Mars is orbited by two moons, Phobos and Deimos. Now, Phobos is larger as compared to Deimos, and you will notice that the shape of these moons are not spherical, but these are potato-shaped moons. Alright? And what is unusual about Phobos is that Phobos revolves around Mars much faster than Deimos. In fact, you could see Phobos 3 times a day if you're on the surface of Mars. You will see Phobos at least 3 times in a day. And that's really fascinating. Now, many astronomers believe that these moons of Mars, Phobos and Deimos, may have been captured asteroids from the asteroid belt. Okay, because Mars is close to the asteroid belt. So probably some asteroids may have been caught by the Martian gravitational pull, and hence they became the moons of Mars, Phobos and Deimos. Now, what about the polar ice caps of Mars? Now, the polar ice caps help us determine seasonal changes on the red planet by the shrinking and growing of the polar ice caps. Now, in terms of composition, the polar ice caps of Mars contain mostly carbon dioxide ice or dry ice, and the polar ice caps contain water not in liquid form but in solid form. So there is water in the polar ice caps of Mars. Now that's fascinating, isn't it? Okay? Alright, so the exploration of Mars was spearheaded by the United States. It was the United States who spearheaded the exploration of Mars with its Viking mission during the mid-1970s. Now, the Viking landers, they carried out experiments designed to detect the presence of microorganisms in the Martian soil. Okay, but unfortunately, the results that was gathered by the Viking landers were inconclusive for the presence of microscopic life. Alright, so that's the Viking lander. And here is a panoramic picture of the Martian terrain taken by Viking. Alright, so again, here is Viking with a panoramic view of the Martian terrain. Okay, now some of the latest Mars information comes from active probes orbiting around Mars and including orbiters and rovers. Okay, so this includes the Mars 2001 Odyssey, Mars Express, Mars Reconnaissance Orbiter, Opportunity Rover, Curiosity Rover, and the latest is the Perseverance Rover, which is now on its way to Mars. Okay, so this is the 2001 Mars Odyssey. Okay, here is the Mars Reconnaissance Orbiter. Here is the Opportunity Rover. And here is the Curiosity Rover that made a soft landing on the Martian surface through a sky crane method. So that's really interesting. And next year, the Perseverance rover will land on the planet Mars with the same method. Okay, the sky crane method. So we are looking forward to that next year when the Perseverance rover reaches the red planet. Well, I guess that's about it for our guided tour of the inner planets of the solar system. Plus, I have given you several theories that explained how our solar system was formed. And I have given you an idea of the scale of the solar system. So I would like to thank those who have watched and listened to this live stream. Thank you po for watching. I would like to thank also the officers and crew of the BEDAN Society of Young Astronomers headed by GC Cascolan, my technical head director, Mr. Cruz Paculanan, my marketing and promotions committee headed by Angel Castañeda, Brielle Ong, and Maurice Katakis. Thank you for helping out. Those who made the pub mats, thank you. So I cannot do this alone. So thank you for helping me made this live stream possible. So always check our Facebook page, especially the students out there, para po sa inyo ito. So check out our Facebook page, the BEDAN Society of Young Astronomers, and please check out also our Twitter account. Okay, so I guess that's it for tonight. So next week, we will continue with the outer planets of the solar system. Okay, so this is Professor June Cajigal from the BEDAN Society of Young Astronomers. So we live long and prosper, and I will see you next week for the second part of this tour of the solar system, the outer planets of the solar system. Always stay safe, and
we choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone.